Hi guys, this is the third video in my series about the XPresso techniques that I use in cinema to control dynamic cars, and today I'll be talking about random steering. Now in this little scene here I've got the yellow car from the first video, and it's more or less the same apart from the fact I've given him four-wheel steering, so that when the front wheels steer say plus 30 degrees, the rear wheels will steer minus 30 degrees. It just means that it twists and turns a bit faster. And also I've given him random steering and a few other little bits of software. Let's just hit play and you can see what I'm talking about. Okay, so he's up and running, and as you can see he's steering around randomly, and he's twisting and turning a bit more because of this four-wheel steer. And I've also told this fellow that when he goes outside of the circle he's got to turn around and come back, because if he didn't have that implemented, the last thing you see this guy be disappearing off into the horizon. So at this point you think, well, why on earth would I want my cars and trucks to steer randomly? Well, this isn't really aimed at cars and trucks, it's more for things like robots and stuff like that. So I'll just hang some high poly models on here, and you can see the sort of thing I'm talking about. So I'm going to hide the body, hide the dynamic body, and reveal the a little mouse here. I've got a computer mouse, so let's hit play. Now I've got a control panel. I'm sure if you watch my other videos you'll know that I'm a big fan of control panels. It means I can adjust things on the fly. Now this mouse, I think I might make him go a bit faster actually. Here we go, speed him up a bit. And if I crank up the amplitude he might twist and turn a bit faster. Oh yeah, that's just what I'd imagine a computer mouse to do. Okay, I've got another little model here. If you can call it a model, it's not very good. I made it myself. It's a Dalek. I don't know if you're familiar with the UK sci-fi TV show called Doctor Who, and one of his adversaries is this little android thing called a Dalek. So let's hit play and see if this guy moves around sensibly. Well, I don't think Daleks go quite that fast, so I'm just going to slow him down a bit. Maybe crank up the amplitude so it'll twist and turn a bit more. Yeah, that's more like it. I think these guys, being circular, they've got a kind of spin on their axis a little bit. So there you go, that's the sort of thing I'm talking about. Now before we get down to the maths, I'll just show you a couple of examples of this random steering in action. Okay, I've got some mouses here, and this is in the Grayscale Gorilla City. And what this is supposed to look like is, you know, if you have, I don't know if you guys have ever lived in some sort of like low rent apartments where you come home one night, you turn on the kitchen light and there's mouses running all over the kitchen floor. Well, this is supposed to look like the Grayscale Gorilla City is infested with mice. So that's mouses. Now what else have I got here? Oh yeah, I got some Daleks here. Here's the old Doctor Who adversary, and these guys are all driving around randomly, and they've got some collision mechanisms in place, but I won't be doing collisions today. I'll be doing collisions in another video. But anyway, these Daleks, when they realise that they're on the screen, they all go over and have a look. Hey, look, Ma, I'm on TV. Okay, so that's the kind of random steering kind of nonsense that we'll be doing today, so let's get down to some mathematics. Okay, well as a starting point for this random steer exercise I'll be using the little yellow dynamic car that I built in the first video. So if you haven't watched my first XPresso car video, I recommend that you do, because I'll be using some of the concepts that I developed in that video in this video. Now this is the car in question. It's the one with the manual steer and the gearbox, etc. And I think I'll just delete all these controls and start from scratch. So we'll get rid of that, and we'll get rid of that. Okay, so I want a null for the control panel. By the way, I'd really recommend that you get into the habit of building control panels to adjust all your variables on the fly, especially if you're going to get into like cloning up these random vehicles and having them all crashing into each other, because when you've got just one control panel to adjust things like torque and speed and, I don't know, bounce and friction, etc., it really does make life a lot easier if you can adjust the global parameters for all the vehicles on one slider. Okay, where was I? Another null for the XPresso. Right click, give them an XPresso tag. Okay, well I think the first thing I'll do is the motors. So here we go, user data, manage user data, add data, I want speed, and it's going to be a float slider, units say, I don't know, 0 to 50 is what I usually use. Okay, I think I'll put a slider in for torque as well. Torque is like the power that goes to the wheels, especially if you're going to have cars crashing into each other. You quite often have to adjust the power going to the wheels. Alright, so once add data, and this one's going to be called torque. Slider, units real, 1000, maybe 2000, to give us a bit of elbow room. But we don't want a step of 1, I think step of maybe 100 will suffice. Okay, speed torque, right, that'll do for that. Right, where's my XPresso window? Okay, now when it comes to controlling several things in your XPresso window, sometimes it's quite handy to use an iteration list. Now if you've never used an iteration list before, I'll show you how it's done. It's quite a useful little skill to have under your belt, so to speak. Okay, so we'll drag the controls into the window, and the thing we're going to be driving here is speed and torque. Okay, now I right click and I make an iteration list, no, an object list, that's what it's called, object list. Okay, now these object lists, they have a habit of kind of disappearing when you click on something, so I always just lock it down. Okay, now this is the motors I'm talking about here, so I'll just drag all my motors into this list. So now I've got a list of motors. I can unlock it now. Okay, now the way you operate these iteration lists is you drag a representative sample in from the interface. I just drag one motor in this case, and I want the object port on the front. And that just means that, see, basically this iteration list, it'll clock through everything on the list once per frame, and it will output each instance, so it'll output motor 0, motor 1, motor 2, etc. And then I've got this sample motor here, so anything I do to this like specimen motor will apply to everything in the list. So I want object properties speed, and object properties torque. Okay, so if I hook this up, and anything I adjust on my sliders, like my speed and my torque, will apply to all the motors. So isn't that a lot neater than having like a whole window full of motors? This is especially true if you've got like very large vehicles with, like, I don't know, 8 motors or something. Your interface starts to get a bit busy, but using this method it keeps it nice and neat. Okay, enough lecturing, let's see if this works. Controls, there we go, speed and torque. Let's see if he goes. And we're off. Faster, even faster, slower. Well, I think we call that working. Okay, so far so good. Okay, now for the steering. If you remember from the earlier videos, what we've got to do is to drag the wheel suspension into this XPresso window. And the thing we're looking for here is steering angle. Okay, so let's just make some copies. And another 2. Okay, and I'll just drag the name onto these so that they refer to the correct wheel suspension. Okay, and if you remember earlier on in this video I said that this is going to be a 4-wheel steer device, so what I need now is a negate node so that the wheels at the back go in the opposite direction. Negate. Okay, we can hook that up. And also I'm going to put a clamp in front of these so that the wheels cannot go at too steep an angle. And I usually clamp my steering at plus or minus half a radian. So clamp. And we go minimum minus 0.5, maximum 0.5. Okay, now we can connect all these fellas up. Front wheels and the back wheels. Okay, one last thing we want is that little trick that I showed you in the first video, is where we need to set the steering it straight ahead for the first couple of frames so that the wheels don't wobble. And if you remember, the way we did that was to grab the frame counts. So we'll go time, delete, frame, and we've got to say when this is greater than 5. So we want logic compare, greater than 5. I'll just write this into its title bar, greater than 5. Okay. Compare greater than 5, and this compare node is usually hooked up to its little brother down here, the condition node. Okay, so greater than 5, we'll select the second one. So the first input is the one when it's less than 5, which is a 0. Just double check. Yep, 0. Okay, so we can connect that up to the value. Now, I think that's just about done. What I'm going to do with this, actually, I'm going to put it into an X group. And where are we? Convert to X group. This will just keep the interface nice and tidy. But this is just basically putting everything into one little window that I can close down. But I'm going to need an input to go into this steering. So on the inputs, I want I think it's going to be real. Yep. And I might as well rename that. I think we've got to ports show names. Yeah, I'll just rename this as steer, and I'll rename the group as 4-wheel steer. Okay, now I can make this a lot smaller. And I've just got a little neat box here with an input that says steer, and we might as well test this, make sure it works, and then we can just forget about what's in this box. We just know that it'll steer. So I'm just going to put a constant on here. Okay, I might have to shrink this a little bit so we can see what's going on. Okay, so if I make my constant, well, let's try it straight ahead first of all. Yep, that's okay. And if I put my steering on, say, minus 0.3, he should steer to the right. So let's just try that. No. I wonder why not. Something's not right here. I never hooked up my input ports. Okay, so when it's greater than 5, it's the second port. Here we go. Connect that up. Okay, now this should work. You always forget the stupidest things. Right, let's try it again now. Straight ahead, and he turns to the right. Okay. Now let's just check that he turns to the left as well. Constant. Say 0.5. That should put him on full lock. Full lock to the left. And it does. Okay, right, I think we'll say that's the steering sorted out. Okay, well now we need to generate some random data and plug it into our steering so we can get this little fella driving around in a random fashion. So we can get rid of this constant node. Now you might think, well, let's just look through the menu and see if there's anything called random. That might just about do it. So here we are, there's something called random. Now this isn't what we want, but I'll show you what is wrong with this particular random node. Sure, it gives you random numbers, but it gives you the wrong kind of random numbers, if you know what I mean. So let's go for real. What real does with this node is it gives you a number between -1 and +1. So let's just hang a results onto here and see what gives. Okay, so on frame 0 it's given us a value of minus 0.394. Now I'm just going to clock through one frame at a time and you'll see the sort of data that comes out of this random node. Next frame, next frame, next frame. Well, as you can see, it is genuinely giving us a different random number every frame, but this isn't really what we want, because if we plug this into our steering, it'll just make the wheels jump from left to right, like every frame's going to be jumping, and this ain't really what we want. We need something a bit more organic to steer this thing. We need more of a gradual changing value, and to get that you need something called a noise node. So let's just find that fella. Where are we? Noise. Okay, now without changing any values, I'll just plug this noise into the result. And I'm going to go through this one frame at a time and keep you down the values. At the moment it's minus 0.3. So here we go. And it's just changing gradually, as you can see. In fact, I'm going to hit play. And if you watch this, you can see it's sort of like varying up and down in a kind of a gradual fashion. Now if you look at the various parameters you can set for noise, there's quite a few things you can adjust. Now I've got a little demo that will show you what's going on, so let's just open that fella up. Okay, well let's set this noise node demo rolling and have a look at the kind of output that it gives. Okay, well what we're looking at here, vertical displacement is the actual output of the node, and left to right is time. So basically we're plotting the noise node output against time. For any of you guys that's done any electronics, this is a bit like an oscilloscope trace. And as you can see, at the moment we're getting quite a nice organic kind of smooth variation, and above the red line is going to be a positive number that's coming out of the node, and below the red line is negative. So this is just the kind of thing that we need to steer our car in a nice smooth fashion. Okay, well let's have a look at the XPresso I'm using to generate this trace, because it'll help you understand a bit more when we get around to using this with a car. Okay, well there's quite a few inputs on this noise node, and I've got a control panel like I usually do. And I've got 3 inputs going into this noise node: the frequency, the amplitude and the random seed. Then I'm taking the output of the noise node, I'm just multiplying it up by a constant so that we can just see it on the display. And I'm feeding that to the Y value of a null that I'm going to trace using a MoGraph tracer. Then to sweep this value across the screen, I'm using a time node just set to time. That's given us seconds, and I'm multiplying these seconds up by another constant, which is going to give us the X position across the screen, so that basically after 1 second the trace has moved 100 units, after 2 seconds it's on 200 units, etc. So this bit at the bottom is just like the time base of an oscilloscope, and the top part is just like the signal input, and that's how I'm generating my trace. Okay, well let's look at the frequency first. This is going to affect how fast the signal changes that's coming out of our noise node, and the higher the number, the faster it's going to change. So if I crank this slider up, you can see that it starts changing at a faster rate of knots. And if I give it a lower value, it will give us a very slow change in value. Okay, well that's the frequency. Okay, well the next slider is the amplitude slider, and as you might imagine, if you make this value larger, it'll just make the signal larger. If you make it smaller, it'll make the signal smaller. Now you might at this point think, well, why do we have to adjust the amplitude at all? Can't we just set it to match the maximum lock of the wheels and just leave it at that? Well, the thing is, if you can adjust the amplitude, like especially to make it larger than the lock of the wheels, you can adjust how often the car is actually on full lock. So if you've got a bit of adjustment on this amplitude, you can tweak the behaviour of your random car. Okay, well the last thing we're going to be adjusting on this noise node is the random seed. You see, a lot of people don't really understand what random means. They think it means it's going to be different every time. Now, although there are nodes in XPresso that will give you a different set of numbers every time, this noise node, it actually gives you a random signal, but it's the same random signal every time. If I just set this rolling, and then I'm going to keep resetting it back to 0, and you'll see that although it's random, it's the same random every time. Now the way you make it different is by changing the seed, so that if I change the seed and reset it, you see now I get a different signal. And I'll reset it and set the seed again, and again, and again. So that's how you make it a different type of random every time, is by varying the seed. Now this is quite relevant if you've got say half a dozen vehicles in your scene and they've all got random steering. They've all got to have a different random seed, because if they've got the same seed they will all move in a kind of synchronized fashion, like a load of guys in a boys band dancing on stage, all doing the same moves all at the same time. And that's not how you want your random cars moving around. You want them all to move differently to each other. Now giving each car a separate seed can be a bit of a pain if you've got like 50 or 100 cars in your scene, but I've got some pretty clever software techniques to do that automatically. But anyway, the golden rule is always keep your eye on the random seed. Okay. Right, so we're going to need some sliders to control our noise node. So manage user data, add data. First one's going to be noise frequency. It's going to be a slider. Real, say 0 to 5, and a step of 0.1 I think should do. And the amplitude is going to be similar values, so I'm just going to copy this fella and rename it to noise amplitude. Okay, and the last one is going to be the random seed. So I'll put noise seed. Okay, this is going to be an integer interface slider. 0 to 100, yep, that should do. Okay, and there's our sliders in place. Okay, so let's get the XPresso window back. Now we don't need this fella, and I don't think we need the result, but we do need some inputs on our noise node. We want frequency, amplitude, and seed. Okay, now where's my controls? Here we go. User data, frequency, amplitude, and seed. Okay, so we can get these fellas hooked up. Okay, now I know I've got a clamp inside of the steering X group, but so I'm going to put a clamp on this one as well, onto the noise, just so I know exactly what's going on in my window. So here we go, calculate clamp. And this is going to be the same kind of values as before, minus 0.5, maximum 0.5. Okay, and you know, I think I'll put this in a little X group as well. Convert to X group. I'll remember to connect the port on this one. I'm going to rename this, what should I call it? Noise steer. Okay, I want an output. This is going to be a real output. Ports show names. Rename this noise. Okay, connect him up. Okay, the moment of truth. Let's join these two fellas together and see if one will control the other. There's two chances, yes or no. Let's look at him from the top. Well, you know, I think that's looking okay. Let's make him go a bit faster. Yeah. Frequency, let's drop the frequency a bit. You know, I think we could say that that was working. Okay, well, I know it's going to need a bit of tweaking when it's all up and running, but I think at the moment, I think we can say that our random steering has been sorted out. Okay, well let's just have a quick look at the scene I showed you right at the beginning of this video so I can remind you what the next stage of this exercise is. Now if you recall, the way this random car operated was that when it was inside of the circle it was driving randomly, and then if it strayed outside of the circle it had to switch its behaviour to steer towards the centre. So let's just have a quick look at this and you can see what I'm talking about. Outside the circle it's got to steer towards the centre, then it's random again until it's outside the circle, it steers towards the centre. Okay, so the next thing we've got to do is to draw a circle and then detect when the car is outside of it. Okay, so I need a circle, and that's going to be in the XZ plane. I think I used 1500 radius before. Okay, I'm going to put another null in and call this one centre of the scene. And in my XPresso window I want to measure the distance of the car from the centre of the scene. So drag in body, and I want global position, just move these out of the way a bit, and centre of scene, global position. Now these are two vector values, but if I use a distance node it will give me the linear distance between these 2 points. So I'll go calculate distance, okay, now I want to know when this car is further from the centre than the radius of the circle. This circle is just there as a visual aid at the moment, but I'm going to leave it in place because it really helps with the old troubleshooting. So I want to know when the distance is greater than the radius of the circle. So drag the circle in. Object properties, radius, and I want to compare one to the other, so I go logic compare the distance to the radius. I want to know when it's greater than. Here we go, greater than. Okay, so let's just move these out of the way a little bit, and I'm going to put result on the end of here and check that our first part of the logic is working. Right, let's see if I can get this down. I might just be able to see it. Okay, so at the moment it's the distance of the car from the centre of the scene is obviously 0. So let's just move the car sideways, and when it gets to the circle, this result should flip over from 0 to a 1, should go from false to true, and there you have it, inside the circle, outside the circle. Let's just try it the other direction, inside the circle, outside the circle. Fantastic. Okay, that's that part done. Okay, well when the car is outside of the circle it's got to change its behaviour to drive towards the centre of the scene. So it's got to know where the centre of the scene is. So to do that I'm going to put a null inside of the car body and point that null at the centre of the scene. Okay, null. Drag him into the body. Zero out the coordinates. Going to rename this null pointing null. Going to give it a target tag. Now I don't need pitch, I just need the header angle, but this fellow is going to be pointing at the centre of the scene. Okay, so let's just look at this from the top down view and make sure it is actually working correctly. Right, I'll move the car over here, and the pointing null is pointing to the centre of the scene. And I'll move the car over here, and the pointing null is pointing to the centre of the scene. Okay, so far so good. Okay, well all we've got to do now is to take this header angle from the pointing null and use it to steer the vehicle back towards the centre of the scene, a bit like we did with the with the Mini going around a city. If you remember in an earlier video where I had this Mini following an object, and it was just controlling the steering wheels. Well, in this particular scene, the maths wasn't too difficult because the target that the car was trying to follow was always in front of the vehicle. But in our situation with this random car and the circle, when this car is leaving the circle, the target that it needs to steer towards is going to be behind the vehicle. So we're going to have to do a bit of clever mathematics to get these angles correct for the steering. Okay, I've got this demo here to try and explain the mathematics involved for when you've got a target that you're trying to drive a dynamic car towards. When the target is behind the vehicle, you've got to do a bit of extra mathematics. But first of all, let's just look at the kind of angles you're going to get when you measure the header angle of an object. Now, these angles are going to be in degrees because that's easier for people to understand. But obviously in the XPresso window, we're going to be dealing with radians. Okay, so when the target goes over to the left, you get a positive value on the header angle. Now that's just like the angle you have to use when you're driving a dynamic car. If you give the steering a positive angle, it goes to the left, and if you give the steering a negative angle, it steers to the right. Okay, so far so good, but what happens when this target gets behind the vehicle? Well, the way the header angle works is that it just carries on getting larger and larger. It goes to 180 when it's dead behind. Then it carries on all the way to 270, and then it flips over to -90. Now this kind of flipping behaviour is the kind of thing that we need to avoid in our programming and in our dynamic cars. We don't need anything jumping from a large positive value to a large negative value. But I've got a way to get around that anyway. But this business of the header angle, reading these values right up to 270, we can actually use this in our favour. Because when you think about it, the first thing we've got to do with our bit of programming here is we've got to detect when this target is behind the vehicle. Now the target is behind the vehicle when the header angle is greater than 90 degrees. So when the target is in either of these two quadrants behind the vehicle, the header angle is going to be greater than 90 degrees. So that's the first part of the little problem solved for us. We just say, is the angle greater than 90? If yes, do some maths. If no, don't do anything. Okay, that's the first part of the problem. The other thing is we've got to calculate some kind of sensible value for the steering. Because just say, for instance, the centre of the scene is behind the vehicle and to the left. We've got to generate a sensible steering angle so the car will turn to the left and then go and find the target. In a similar fashion, when the target, that is the centre of the scene, is behind a vehicle but to the right, we've got to generate the kind of steering angle which will make the car turn to the right and go and find the target, which is the centre of the scene, obviously. Okay, well, how do we do that? Well, I've got a solution now. It's not perfect, but it's pretty good. It's pretty close. Here's my theory anyway. Let's say, for the sake of argument, the target is here, and we are reading a header angle of 160 degrees. Well, if we subtract this 160 degrees from 180, which is the exact sort of straight behind value, this 6 o'clock position here, that's 180. So if our angle was reading, say, 150, like this, if we subtract this 150 from 180, that gives us plus 30. Now plus 30 is an angle that will steer the car to the left. So if we just take this value from 180 and substitute it for the steering angle, it will steer the car to the left. But what happens when we're in the other quadrant? Well, let's just test this theory. So let's say, for instance, the car was over here. Sorry, the target was over here behind the car. And we've now got a header angle of 200. Well, if we take 200 from 180, that gives us minus 20. Now, minus 20 is a steering angle that is to the right. So that would steer the car all the way back, and it will find the target, which is the centre of the scene that we're aiming for. Okay, well there's only one, that would work. There's just one thing we need to do. We need to clamp this value because we don't want the value we're computing to get larger than, well, my usual ballpark figure is half a radian, which is about 30 degrees or so. So if we do this calculation and then clamp the value, I can show you what you get, and it does actually work. I've got it here actually, I'll just unhide that. Okay, right. The red is the one we've just been looking at, the header angle. Okay, now the yellow is the calculated new steering angle. So here's the deal. The target's to the left and it steers to the left. The target's to the right and it steers to the right. When the target's too far, it's clamped. So see there, the yellow can't go any further, and the same is on the right hand side as well. When the target gets all the way around to the back, because it's greater than 90 degrees, in this part of the quadrants, we're doing the calculation. So we'd say take the number away from 180, and look, it's given us the sensible value. And to the right here, it's given us the correct value, and it's clamped as well. So how about that then, eh? And also this business of it flipping over here, because this takes place during a region when the value is clamped, this doesn't affect anything. So that basically is how it all works. Now I've got this written out in English, so to speak. Now this isn't code or anything. This is what you might call pseudo code. This isn't any kind of programming language. It's just written out in English. And here's what we've got to implement in XPresso. If the header angle is greater than 90 degrees, then use 180 minus header. If this isn't true, just use a header. That's what this means. And this is basically how it works. So as you can see, with the targets at the back, we are getting sensible angles. This would make the car steer to the left and go and find the target. This would make the car steer to the right and go and find the target. And when the target's at the front, it just works as normal. Okay, that's my bit of maths, and I rest my case. Okay, well let's implement this bit of mathematics in our XPresso. Right, so we're going to need the pointing null, and we want the pointing null's local header angle, not the global, we want the local header angle here. Okay, now the test we've got to do on this header angle is it greater than 90 degrees? So we need compare. Now don't forget we're using radians here, and 90 degrees is pi divided by 2, or as us engineers call it, pi by 2. Okay, so this is the test. Greater than, you can type pi and stuff like that straight into the fields here and it'll compute it for you. So our test is pi divided by 2. If I hit enter, that gives you the correct values of pi by 2. Okay, so we're comparing it, and then we're going to need a switch, obviously, to switch these over. A condition, I should say. Right, so that's my test. Is it greater than pi by 2? Now if it is greater than pi by 2, I've got to do that little sum, which was, if I can remember correctly, it was take the number away from 180 degrees. Now 180 degrees in radians is pi, so we've got to subtract, change this to subtract, and we're subtracting our number from pi. Okay, so far so good. So that's the test. Is it greater than 90? In fact, let's just rename this so we know exactly what we're doing. Compare greater than pi by 2. Okay, that's the test, and if that's true, then we subtract our value from pi. So that's going to be, when that is true, it gives us the second input, but if it's not true, we just use this value, just go straight through. This is the else part of that thing, when I said here's a bit of pseudo code. This is, if it's greater than pi by 2, use this value. If it's not, just use the regular value. Okay, and then we just need to clamp this value to plus and minus half a radian. Now I know we've got loads of clamps all over the place, but it doesn't do any harm having the extra clamp here and there, so you know that everything exactly is confined in the ranges that we're interested in. Okay, minus 0.5 minimum, 0.5 maximum value. Okay, now I'm just going to hang a result on here and test this if I can make enough space to see all these things at once. Okay, how can I do this? Just scrunch this up a bit. Okay, now I've got my car here, so let's look at it. It's looking at the centre of the scene. So at the moment it's reading a low value, virtually 0. So when the car is this way, it's reading a positive value, and when it's this way, it's reading a negative value. Now what happens when the centre of the scene is behind the car, which it is now? It's given us a negative value of almost half a radian, which is exactly what we wanted. And when the when the centre of the scene is behind and to the left slightly, it's given us this half radian, which would steer the vehicle around. Whew, okay, so I hope you're following all this. It's all good stuff, innit, eh? I bet you wish you'd paid attention at school now. You thought you'd seen the last of Pi, didn't you, eh? Okay. Okay, well I think we ought to put this this little calculation in an X group so it doesn't take up so much space in the window. So just like before, I can highlight all of these, right click, convert to X group. I'm going to give it a name. What can I call this one? Steer to center. Okay, and I'll put a port on the output side. Now what's this going to be? It's going to be a real number. Yep, real number, and we'll call this one steer, I think. So we'll just connections, where are we? Ports, show names, rename it steer. Okay, connect this fella up. Just minimize this window a little bit. Okay, so there's steer. Now the whole point of this exercise was to use this this compare thing. Compare when the car is outside of the circle. We've got to switch between noise steering and steer to center. Okay, so we're going to need another little condition node here. Okay, now when this when the car is outside of the circle, this is going to be true, so it's going to switch the second value through, which is going to be the steer to center one. Okay, steer to center, and the noise is going to be the regular behavior, so to speak. And that's the switch, so let's connect up the steering. Hey, look at this stuff, it's all modular programming. Well, like I always say, there's got two chances now, it'll work or it won't. So let's set this fella rolling. And we're off. And it's steering randomly. And it's outside the circle. Oh man, would you believe it? He's coming back in. Yay! Oh, this is just too much. Let's just crank the speed up a bit. Outside the, oops, I've run out of frames, not to worry. Let's just give ourselves a few more frames here so we can see what's going on. 1000 frames. Okay, here we go. Outside the circle, turns around and he comes back in. And he goes out again and he comes back in. Okay, now there's just one last thing we've got to do with this little fella. Now as you can see, it is working, and all we've got to do really is tweak some of these values. But the one thing, do you remember right at the beginning of, I don't even know if I mentioned it, I think I did, that one problem you have with vehicles like this, or any kind of programming problem where you go across a threshold and the value changes, is that the thing can end up oscillating on the threshold, which is, I think this this car was just about doing that. Let's just move him over to the side and see if it does kind of oscillate a bit, because there is a solution to this. Okay, he goes out and he comes in, and just to prove me wrong, it's not doing it. Come on, guide, don't let me down here. He goes out and he comes in, and he goes out again. Ah, right, that's what I was trying to point out, can happen quite easily. These things can end up oscillating just near the edge. Okay, right. Now for the solution to that, which involves monoflops. Okay, well the problem we're trying to solve basically is that where we've got this little test that says is the car outside of the circle, and when the car comes back in the circle it goes from true back to false again. What we need to say is that when this goes from true back to false, we need to put a delay on it so that it doesn't happen straight away, so that when the car is outside the circle and it comes to go back in the circle, we don't say go straight back to random behaviour, we say don't go back to random behaviour until you get about this far in and then go back to random behaviour. That'll just give us enough clearance so that the thing doesn't oscillate on the edge of the circle. Okay, so that's what we've got to implement here. We've got to break this chain here and put a kind of a delay in place. So let's just move these fellas over a little bit. Just delete that null. Okay. Here's where we've got to put our delay. We're going to implement that delay by using something called a monoflop. Here we go, and a monoflop is basically a timer, and it's got an input called time because it does need an input from the time node so it can do its calculations. So here we go, we just connect that time up to there and it can do its counting. Alright. Now this monoflop, it works on zeros and ones. There's no analog signals or anything going on here, it's just zeros and ones. And it's got two functions basically, this monoflop. Now I'll show you the one-shot one. We're not actually going to use this, we're going to use the normal function, but the one-shot is easier to understand. When it's on one-shot, the monoflop works like this. First of all, the output has got an output of 0, so this is how it starts up. The output is 0, then a trigger comes along, so the trigger port goes from 0 to 1. As soon as the trigger goes high, the output goes high, and it stays high for a length of time equal to the duration. Now the duration can be set in frames in the interface, or you can set it, if it's done within the XPresso window, it is set in seconds. But that don't really matter at the moment. You've got to understand what's going on with these triggers. So in the one shot, the trigger goes high, the output goes high for the length of the duration. In what they call the normal mode, the way this works is that the trigger goes high, the output goes high, but it doesn't start counting. So when the trigger is high, then the trigger eventually falls back to 0. When the trigger goes from 1 down to 0, that is when the output starts counting, and it counts for the duration that we've got on this port. So this is exactly what we want on our little problem here. So when the car comes into the circle, so when the car goes out of the circle, it'll turn the monoflop on. And when the car comes back into the circle, as it crosses the threshold, it will then start the counting. And it'll start the counting for, say, half a second or whatever we set it to. And then once the car has got about so far, it will then switch back to being random. So that's what we've got to implement here. So let me think now, what have we got this set on monoflop? Got it set on normal, that's what we want. And I'm just going to set it to an arbitrary value of, say, 15 frames. We can maybe put a slider on this later on, but at the moment we've got it set to normal, got it set to 15 frames, and we've got the time hooked up, so we just need to connect this to that. And we'll connect the switch to there, and let's just see what happens basically. So when this fella goes out of the circle and he comes back in, he should carry on steering straight to the centre. That's going to show us if the monoflop is working, if this guy carries on steering in a straight line. So come on, random car, do your stuff. I'm just going to put my finger over the button here to control the starting and stopping. Right, so he's coming back into the circle. Now I want him to carry on in a straight line. And oh man, would you believe it? How perfect is that? Straight line, then back to random. Holy moly. You know what, I think we could just about say that this random car is nailed. So all that's left really is I could do with maybe putting a slider on that duration for the monoflop for this fella here, just so we can control everything from the control panel. So, where's my controls? Manage user data, add data. We'll call this re-entry delay. Don't forget this is going to be in seconds because we're going to be implementing it in the XPresso window. Okay, slider, reels, say 0.1 of a second. That should do to maximum of say, I don't know, 2 seconds, just to give us a bit of leeway. Intro delay, yeah, that should just about do it. Okay, so back to our window, drag the control in here, re-entry delay. Okay, now let's just test if this re-entry delay works, because if I have this set for a high value, I think I had it set for 15 frames, which was half a second. So if I have this set for say a shorter value, when it comes back into the circle, the straight line business should only happen for a shorter period of time. That didn't seem to, oh yeah, there we go. It is working, yeah. Let's try it for a longer period of time. It should come right almost to the centre now. I'm not sure whether this is working. I've got it set to 1.5 now. Yeah, it is working, yep. Okay, so all that's left now is really a bit of tweaking. So I think I'll just press pause now and go and have a cup of tea. Okay, well all that's left really is to test that these sliders actually do something. I mean, it's not unlike me to have forgotten to connect them to something. So let's press play and check them out one at a time. Okay, the speed, 0, yep, it makes it stop. Full speed, yep, that seems to work. And the torque doesn't really do anything until you have several cars. The only reason I've got it included is when you have more than one car and they get stuck, if they sort of get jammed up against each other, sometimes just cranking up the torque stops them getting stuck. But I can just test that the torque's working by just turning it down to 0 and the car should stop. Yes, it does, and put it back up again. Okay, the torque seems okay. Now the noise frequency, that'll make the car steer left to right a bit faster if I crank it up, so let's just try that. It's on 0.7, so I'll go to 2.7. Only applies inside the circle, obviously. And as you can see, I think it's twitching just a bit more. Let's even see it from the top. Yeah, it's definitely twitching faster. Okay, I can put the frequency back down to something a bit more sensible. Now the amplitude, what this is going to do is if I crank up the amplitude, it'll make it on full lock, make the car be on full lock more than it would normally be. So if I just turn the amplitude up, say to something crazy, it should spend a lot of time on full lock, and it is doing. This might be useful if I stick my dial-link model on this car, because it'll spin a bit on its axis. Okay, so that's the noise amplitude. The seed, let's just double check that the seed's working. What this should do is if I change the seed and then reset it to 0, it should go in a different direction. So it goes off to the right and turns to the left a bit, so I'll reset it and a different seed value and it goes to the left. So I think we could say that this seed is changing the way it drives around the scene. Okay, re-entry delay, that's the last thing to check. I know, I'll put it right down to 0 and see what happens. When it comes back through the circle, it should go straight to the random steer, and it does. Okay, now I'll put it on a fairly high value, and when it comes back in the circle, it should go almost to the centre before it goes back into the random. Yep. Okay, well I think that's just about road tested, so let's just look at some 3D models. Okay, well I've got a little computer mouse here and it's actually got a flashing scroll. The scroll flashes for some reason. So let's stick him on our random car and see what he looks like. I might even include this in a download if I'm feeling generous when I upload this video. Where are we? Copy. Here's my dynamic random car. Paste. Oh, it's not too bad size wise. Let's look at this from the side. About there should do it. Just drop him in the body. And I'll hide the dynamic body and reveal the mouse. Okay, let's hit play and see what happens. And there's our little mouse. Let's see if we can make him twitch a bit. Amplitude. No, the frequency. Let's turn the frequency up and the amplitude a bit. Here we go. Yeah, he's hunting around looking for crumbs. Our little mouse. Okay, so that's the mouse. I think I'll try my Dalek as well. I don't have to remove this mouse. I can just hide it. Okay, now where's my Dalek? Dalek body. Okay. Copy. That mouse needs hiding. Okay. Paste the Dalek. Well, that's not too bad size-wise either. Yeah, I might just get away with that actually. Lift him up a bit. Okay, so I'll drop the Dalek into the dynamic body. Hide the body, reveal the Dalek. So let's see what this fellow looks like. Well, he's zooming around a bit fast actually. I think I'll just slow this fella down a bit. And frequency. Yeah, that's not bad. I think that's what Daleks look like when they're fighting the Doctor Who. Okay guys, that's about it. That's about it for Random Steer. Now the next video I'll be making, it'll be about how to get these guys crashing into each other and doing some kind of avoiding strategy. But for now, that's about it for Random Cars. I'll catch you guys next time.